We'll just ask everyone to mute themselves just so we don't get any feedback. That would be great. So welcome everyone. This session is our second one for this and last one for this year on Matter. And because you are getting a registration reminder already, you don't need to register for the rest of them. You're automatically rolled over for the continuation when we start again in October, and then we do the ones that happen in December, and then for some of you in February. So it will be just an ongoing series. You don't have to re-register for them at all. So welcome aboard. My name is Chris Arski. I'm one of the consultants with the CART Consortia, which is out of Central Alberta. I'm coming to you today from rainy Camrose. It just started pouring out of the blue just the last few minutes. And I hope for those of you that were with us yesterday, I promise you today we will have a better tech opportunity. I'm not sure what went wrong, but yesterday we had some glitches. Today we seem to have gone through it and we're good to go. I have the pleasure of working with a fantastic partner, Ted Zeroni, and I'm going to get him to introduce himself as well, please.
Hi, everyone. My name is Ted Zeroni, and I'm coming from Sherwood Park right now, or I'm at Sherwood Park right now, and I work with the Edmonton Regional Learning Consortium, and it's a pleasure to be here with you this afternoon. And thank you again, as Chris mentioned, for taking the time out of a very busy time of year to be with us this afternoon.
Okay, so we're going to unpack Matter, and that would mean that you now have both living systems and Matter. We purposefully chose living systems because of teacher, first of all, recommendation, and secondly, because it contains some of the big concepts that kind of rolled right into Matter. And then from Matter, it kind of rolls right into Earth systems. Like they just are linked together. So we did not change the order in which we're doing these. But nonetheless, you still have the right to do them in any order that you want. So just because we're unpacking these two doesn't mean that's where you have to start. You're absolutely more than welcome to start anywhere else. Just be aware that this is now a spiraled curriculum. So it's not one in which we kind of teach science in a box. You don't have your 5 topics, and when they leave you, they're done and they don't have to visit that again. You very much have the concepts that are going to build for the next grade. And so for you as grade 3 teachers, you're going to need to remind yourselves to go back and find the big concepts that lived in kindergarten, grade 1 and grade 2 that carry over into grade 3, because they won't have that background arriving at your doorstep. They haven't had the privilege of going through the 3 years already. So we will highlight what some of those are. Ted will take you through the progression of those concepts, and so that you can see what they look like and what bits and pieces you might need to pick up along the way. So for those who are not aware of sort of when we do the acknowledgement, every series that we bring to you, or every time we bring a new organizing idea, we will embed something different in the acknowledgement, whether it's a video, whether it's a link to some resources. In this case, because we're talking very much about matter and the objects and the properties of matter, we also refer a lot to the natural land and the land use of natural products. So in our acknowledgement today, what we're looking at is a Venn diagram. And remember, a quick reminder for those of you who haven't heard us say it before, the Venn diagram is one of the most powerful assessment tools that we can use in any subject. It allows us to have students show us what they know, demonstrate their learning, and they can't just do it with facts of 2 things. And I have to know something in order to make a comparison. So in this case, what we're comparing is on the left-hand side, traditional Indigenous or Native knowledge versus Western science. How do those 2 compare? Like, where do we find common ground? And where are things quite uniquely different? So when you're reading them across, you can kind of go bullet to bullet. So a holistic approach for a traditional Indigenous lens, when I'm looking through it, whereas we look at it more as a part to whole. Where does this part fit into the big picture? If we were to say, you know, what is if we're talking about a food chain, what's the ultimate at the end of a food chain? And we would say man is. And if we're looking through an Indigenous lens, man doesn't carry any more weight or more importance than a grasshopper or a piece of grass, because everything is important and has that same important level. So there isn't that hierarchy that we would establish. So we offer that to you just for information. If you've never had a chance to really consider how those two compare, it would be well for us to know that, because as we're teaching students, we also want to make sure that we're presenting both sides and that all students see themselves within the classroom. The link to the original document is at the bottom, and so you're welcome to use that as well. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So our layout for every session that we do with you, each organizing idea would be very similar to what you're seeing here, with few exceptions. We'll always give you some backgrounders. In other words, what happened before grade 3 that will be important for me to know in matter? Like, what do they carry through in kindergarten, grade 1, grade 2 that I need to be aware of? I will share those with you, and we'll give you pieces of the slide decks that actually fit from those grades so that you can see it. You can do some pre-assessment with the kids. Maybe they already know some of this, maybe they don't know some of it. So it'll give you a little bit of a starting point. We are not in any way saying, though, that you are going to go back and reteach all of kindergarten or all of grade 1 in any one area. You're just going to grab snippets of the concepts that live in yours and that we have to make sure they understand. So don't panic. Don't think, oh my gosh, I'm never going to finish because I have to go back and reteach 2 grades. And the answer is no, you don't. So we'll talk about the understandings, which are the most important of the 3 columns in your CUS. And Ted will unpack the linkages between the concepts and skills and procedures. We'll talk a little bit about what would assessment look like? What would it look like at a surface level? What would it look like at a deep or a transfer level? And then we'll also talk about integrating computing science and scientific method. And then we have lots of resources for you that we'll share. So very quickly, I'm going to go through what is kind of carried through from kindergarten that's important. So again, I'm just touching on this. And when we show you where you find your resources, you have access to every grade. So if you're finding something today, you hear it and think, oh, I think I might need to go back on that. Just jot it down and you can go grab it from the file folder. That's not a problem. So one of the things that we do a lot of, and we did it in living systems in particular, but we do it here as well, is sorts. So a card sort, if you've never done a card sort before, you might want to have a look at the steps that Ted has outlined for you on how to do that. You might want to watch one of the videos from Living Systems where we show you how to do it. But in any case, a sort offers me a lot of pre-assessment of what the students already have as knowledge and what they lack. Where are the gaps? Or maybe there's no gaps, or maybe they don't know any of the pieces that I need them to know. So I can use a card sort for that, and it's a skill. It really is. So there's where the link is that I won't go into it now, but you can click that on. You're going to get the slide deck. So you'll be able to go in, just click on the link. And that will give you an opportunity then to go through and have a look at what it looks like. Ted, do you want to go through any of these?
No, we won't go through any of those right now, but there'll be a list of them. These will all be available to you. The link is live when you get the slide deck, but you also get a list of these on a separate sheet. And these include some concept introductors, I suppose. So if you've never introduced property to your students before, you could click on here, and most of them are going to be that concept attainment activity. And I'll demonstrate one later on in this presentation of what a concept attainment looks like if you're not familiar with it.
They just spent a fair bit of time already talking about what is an object. So students need to be able to define that as early as in kindergarten. So we talk about objects. We talk about what the properties of objects are. And that's an important word. The word property shows up in multiple grades thereafter. So that is one of those big rocks that we really want to make sure that kids can unpack. And if you think that that might be an area that you're going to struggle with, I would go and grab some of the terminology around properties from kindergarten and link it to grade 1 because it falls into grade 1 as well. And those are areas that's one of those big rocks that we want to have. Oh, sorry, I went too fast there. We also talk a little bit about the senses. So old grade 1 science had senses in it, but that's a huge component when a student is trying to describe the properties of an object. So I have to be able to name the properties and how will I describe them? And I use my senses to do that. So again, if they don't have a strong background in that, you might want to spend a day just unpacking a little bit of that, doing some activities that were suggested even, just to get them up to speed. So we define for them the difference between an object and a property. And we expect them to use science terminology right from kindergarten up. We are looking for them to give us an explanation, but it's like, can we also get the terminology surrounding that explanation to be scientific as opposed to simply just lay language that they would use every day? So again, if they need a little bit of work on senses, you've got some slide decks, you've got activities there that you can use. Here's an example of the card sort. This would have been sort number 3 already in kindergarten. So they would have done it once without any parameters. They would have done it again with some parameters. Now we're saying, can you resort your cards based on the senses? So what would go where? And then the students start to develop the understanding that some of those cards go into more than one sense. And how would I show that? Okay, we're getting into the Venn diagram thinking already, right? They fit in more than one circle. So where will I put them? So we have a conversation about that. We started a word wall, is what we suggested in kindergarten. Just using everyday language that they give you when they first start off doing some descriptive language. And then we start to expand those properties. What are some descriptive words that we can use for the properties and for the senses that go along? Moving into grade 1, we also still talk about sorts. We still talk about properties of objects. So there's that important carryover yet again into grade 1. And this particular slide is also highlighting the fact that really this portion of the science curriculum should be happening in parallel or in tandem with math, because they're really doing the same thing. And students shouldn't see that I sort only this way in math, I sort only this way in science, that they happen at the same time with the same parameters, the same kind of thinking that goes behind it. It just might be that I'm sorting different attributes, okay? So that's one of the links that we wanted to make. They unpack basically the measurable properties in grade 1 of matter or objects, and we talk about what kind of tools they might use. So that's another piece that we want students to be able to do. What tools would I use to describe and measure an object, its properties? How do I describe the change that might occur? What are change actions that I can twist something, I can stretch something, right? I can break something. So those are the actions of change. We talk about descriptive properties such as length, and they're really only using descriptive or comparative language here. We're not asking them to grab a ruler and measure something. We're saying, is it taller? Is it smaller, shorter, longer, fat, wide? Like, what are the words that would give me a length description, just as an example? I could use Cuisenaire and they could say, well, an orange is longer than a yellow, right? Or I could tell that I need 2 yellows to make an orange. That gets into the math, but it's also part of what we're talking about here for that descriptive language of length. There's a video here, and that video also includes how I might measure if I'm not using a ruler, which gets a lot into grade 2, but it also seems really appropriate to have it here. If I were to use even a piece of stick that I see there, I can compare the sticks, but maybe I take a stick and say, my shoe is 2 sticks long, right? So that might be another way that I use it. So it's just using a non-standard unit for measure. This one will talk about paper clips and other ways that I can measure. We also talked about area in grade 1. So area is the correct term that we are looking for, but really they also preface it, it's in brackets. So we might want to use lay language such as how much surface is being covered. We were using the term area. We felt that the kids were ready for it, but that's entirely your call. You would make that decision. And in this case, we're not doing any formulas. It's just put something on a grid paper and which one covered more of the squares, right? That's the purpose of having the grid underneath, is they could count the squares and say, oh, the can covered more than the little box of tea or the other way around? How much area got covered by the circle? Which circle has more area inside of it? So which one has less? Which ones are in between? It's that comparative language again. And then we also talk about mass and weight. And so this is still coming from grade 1. How can I show the difference? What is the difference between mass and weight? I could do it again. I could bring out my scales. I could use my Cuisenaire rods. That 2 different numbers. I can create 12 2 different ways using Cuisenaire rods, but they're weighted and they should be balanced out. Again, so these are things that we need to teach students. You can't assume that they know how to do with a weigh scale. I need to show them how to basically read it, but also what would I do with something as a tool like a magnifying glass, and what's some safety things that surround a magnifying glass. So again, just simple tools. You'll see at the top, I put a note here that we talk about non-standard units that we could use to measure something, but the term non-standard is specific to grade 2, not grade 1. And then sort of the culminating piece for grade 1 would be, if we're going to talk about mass, for example, or changes, how can changes occur in an object? So if I take a cookie and I crumble, that's what that video is. If I take a cookie and crumble it, I still have the same amount of cookie. It doesn't look the same, but what's powdery and piled up on my plate is still the same cookie, just looks different. So it's changed its shape, but the amount of mass has not changed. And so that's what we ask them to do, is compare what has changed. Is it length that's changed, area, shape, texture, or weight? And we give them a card sort. So when you click on the card sort, you get a bunch of pictures. They have numbers at the bottom, and we ask them to put the numbers of what's being changed in the picture. And in some cases, those numbers will show up in more than one particular column, because it's not just the length that changed. Maybe it is the weight that changed. It's never going to be the mass necessarily that changed. Okay, so let's move on. So directly from grade 2, we introduce the word, we introduce the word materials. So we're moving from object to materials. So now we're looking at what makes up certain materials. What's the composition of it? So what's a natural material? What's a man-made material? Can I look through it? Is it transparent? Is it malleable? Is it hard? Is it rigid? Is it long? Is it short? So still using some of that comparative language, but now I'm paying more attention to what made up the material and what would its uses and purposes be. So again, and then the other piece is that we want them to test. How do they test for the properties of the material? How did they know that it was opaque? How did they know that it was transparent? So just doing those simple activities with a variety of different materials and objects would be helpful to move the students forward. There's a video in here that I would strongly suggest starting with in grade 3 anyway, regardless. Just again, talking about what is different materials. And this one goes through all kinds of materials, from a balloon, rubber, to a piece of wood. So just looking at sort of common materials that we see on a day-by-day basis. Yes, we know that things are made out of those materials, but just to identify the materials and what are their properties. And then at the end of each one of those, I would pause the video, because it even says pause and just say, can we come up with our own examples? So that will give you a good pre-assessment about what their knowledge is in those areas of just materials and what's available. What have they been exposed to? So again, properties of materials are listed on this particular site. Those aren't necessarily the only words that they might come up with. They might come up with some more common language as well. But these are some of the pieces. We want to also replace like see-through with transparent and the proper terminology. But to start with, this is a good place. Bending, folding, pulling, tearing, twisting, all of those different pieces. We want them to be able to say that those might be properties of materials. I can take some fabric and cut it. I can tear it. I can bend it. I can fold it. I can scrunch it up. Like all of those different pieces is what we want them to be exposed to. And then how do I test for the properties of a material? So that's one of the skills that they're asked to test some of those materials. So go through the process of exposing them and testing them and picking them up and holding them, and can you break it and can you bend it and whatever. And then in addition to that, we just kind of added in a little bit about, so where do all these materials come from and how does everybody come up with all these different properties? Like, does everybody just reinvent the wheel every time we pick it up? And the answer is no. There are actually people called material scientists whose job is to either create new kinds of materials that can be used, new types of aluminum surfaces, different kinds of things you might use on a car, different kinds of plastics that don't melt anymore that they used to have years ago. If something got hot, it would melt right away. Well, now we don't have that. So these are the roles of material scientists, and also to test for properties of certain substances or certain kinds of materials that have come up. Introducing that Venn diagram is an important one. Can they start making some comparisons? And by the time they get to grade 2, they've had, in a perfect world, 3 years of this kind of language already. So they've amassed a bit of information. So they should be able to do a simple Venn diagram, and you could change this up and put different words in there. Remember that a Venn diagram is a comparison. And the best way to do that, simplest way, and not maybe the most routine way, is just get some hula hoops. Go to the dollar store, Dollar Tree, buy a bunch of hula hoops, put them on the floor. And when I link them, I've got a Venn diagram. I get the kids out of their seats. I can put some terminology in one of them or 2 of them and give them some cards or whatever you're asking me, or objects in a bag. And they could be 6 different stations around your room, each of them focused on something slightly different, where they're just creating the objects that they're going to put in there. And then you can walk around and ask the more important question is, explain to me the thinking of why you put the things in that you did. They can work in partners, doesn't have to be separate. Okay, so when we look at grade 3, we want to look first of all at what are the concepts and how are we going to unpack them to grade 3. So I'm going to turn it over to Ted and he'll pick it up from here.
Thanks, Chris. If you've seen our session 1 that was recorded or with us during the pilot sessions, you've seen this diagram many times. And I'm just going to bring it up again just to help understand how the rest of this presentation is going to go. And the previous presentations for kindergarten, grade 1 and 2 went through the same process. So if you look back those videos to perhaps see some of the things that Chris was talking about in the background, you'll see the same presentation. We're looking at this curriculum and the organizing ideas through that lens of the phases of learning, of surface, deep, and transfer. And once again, just in case you missed, you haven't still looked at session 1 or weren't here for our pilot presentations, the surface phase of learning is where kids learn the facts, like things like birth dates and so on, things that are just facts to memorize. It's at the point in the learning process where they learn the basic skills. So whatever it is that they're going to be doing later on in the unit, or later on in the cusp line that you're presenting, what are the skills that they're going to need to bring it all together? So it may be comparing, contrasting, like Chris was alluding to earlier before. It could be discussing. It could be any of those things. It's at the surface level, the beginning of that whole thing, that we want to help kids understand what the skill is and practice using it a little bit without necessarily getting into the content of the course. And same with the concepts. Chris mentioned a lot of those concepts, such as purpose and property and so on. At the surface level, the students not only create a definition for it and can restate a definition for it, but it's also being able to distinguish between examples and non-examples. And that's why we give it that concept figure, a 3D look. It's more than just the definition. It's not just a vocabulary. It's a concept that lives and has examples in a variety of contexts. So that's where we bring it out. So once students are familiar with the concepts that they're going to need and the skills to demonstrate their understanding, we can get working with the understanding piece, which is the deep learning part. It's where we put those different concepts together in a statement of a relationship. And you'll see those statements in the middle column of the curriculum. So we're working at the deep level when we're helping kids to test those understandings or develop those understandings and those relationships, or to identify those understandings in a variety of contexts. That's why I have an orange background in the deep component, because we keep on giving students opportunities to look at that understanding through different contexts until we feel we get to a point where they can transfer it to a completely different context, same understanding, but a different context. And we'll give some examples later on. But that's why the three cube figure remains the same in deep and transfer. We're working with the same understanding. We're just simply changing the context in which the kids are working with that understanding. So Chris, if we can go to the next slide, we're going to just focus a little bit more on the idea of concepts and skills for just a couple slides. All the concepts in this organizing idea are listed here in this concept map. Maybe from where you're sitting on your screen, it may be hard to read, but you'll get a copy of this as well. But they do help to give us a big picture of what the organizing idea is about at grade 3, in this case, matter at grade 3, and some of those key concepts that may show up or that will appear in the organizing idea. And the way to read through this, when you can get a copy and zoom in and make it a little bit bigger, is fairly straightforward. There's lots of words that kind of describe the relationship that exists between the ideas. And I'll just read through a couple of them to give you an idea of how you can do that when you do open a copy for yourself. So we begin at the top, and I'm going to begin like matter exists in a state, following down, and the state is solid, liquid, or gas. And those states have certain properties to them. And there's that property word again that Chris alluded to earlier that we look at in kindergarten, grade 1 and grade 2, and again in grade 3. So it is one of those big things. Starting from the top again, matter exists in a state, and moving back up, that can change because of heating or cooling. And there's we know when we're talking about heating and cooling, we're talking about freezing, melting, boiling points. And when things are heating and cooling, when we're talking about water, it creates a water cycle, and the idea of cycle is there as well. We also know that matter exists in a state that can change, and that change can be permanent or reversible. So that's how you read through these concept maps when you see them, and it gives you a sense of what the organizing idea is about. So if we can move to the next slide, Chris. This is available to you. There's one for each organizing idea. We call this the concept progressions because you can see at the bottom part where the key concepts are. We've pulled out the big one, the important ones for each grade in matter. And when you look across, you can see a lot of them do repeat themselves. So properties is identified again in kindergarten. Those are observable properties. In grade 1, we're talking about measurable properties. In grade 2, we're talking about testable properties. You can test the malleability, you can test the transparency of objects. We're also looking at how objects can change in grade 2. And in grade 3, properties are included. It's not there, but it should be properties. The different states of matter have properties as well that can be either measurable, changeable, observable, and testable as well. Not necessarily testable, but measurable and observable for sure. So at that surface level, we're going to be working with these concepts, and we're also going to be looking at the skills at that surface level as well. The next graphic shows you all the skills that we're going to be that you can work with at the grade 3 level. This particular graphic was developed by taking all of the skills and procedure statements from K to 3 in all of the organizing ideas, right from matter to computer science to all these things. Well, no, computer science and scientific methods is kind of embedded in there, but not quite. And I'll show you a graphic later where it identifies those skills. But you can see there's quite a common list between kindergarten and grade 3. And those are the things that, we want to make sure that kids, if we're going to get them to do with the activities or at the end of the cusp that's in that skills and procedure, we want to make sure that they're familiar with those and practice those at the front end at the surface level. So we want them, if they've never done comparing and contrast before, or if you give them some activity to see if they compare and contrast very well and they don't quite get it, we're going to want to spend time to make sure they're good at it. Do they know what observations are, for example? Are they good at observing? And again, that's using all of their senses with observing. Same with predicting and so on. So those are the skills that, just because they don't show up in the skills and procedure statement, At some point, they're going to, and it may be a good idea to keep on coming back to those and helping kids become good at each of those skills. You notice that some of them are highlighted in a dark shade and some are highlighted in a light shade. The dark shaded skills are ones that do show up specifically in the skills and procedure statement through one or more of the organizing ideas. So kindergarten, for example, asking questions shows up in the skills and procedure statement. The light shaded one boxes mean that the skill is not stated specifically. You won't see ask questions in any of the skills and procedure statement in grade 3. However, it is part of the investigative process, which we'll take a look at a little bit later on. But if you go down that list and find investigate there, we see that students do investigations at grade 1, grade 2, and grade 3. And the first step in investigation is ask questions. So anytime you see a pink shaded in box in that list, it means that it's embedded in a procedure or somewhere something, or it's significant enough that should be continued on. So those are the main skills and concepts in not only in matter that you'll find along the way or grade 3 along the way. So let's go back to our phases of learning and see how we put that together. So we are the way Chris and I are gonna present this, which is different the way we presented the living systems organizing idea in earlier in May. Instead of presenting all the surface stuff and all the concepts and all the skills of the front end and moving to deep, we're going to work at this on a cusp line, because it really, at the end of the day, we want to develop those understandings. And so we're going to take a look at each cusp line, take a look at what we could do at the surface level and how we can work at the deep level with that. So the surface level, again, does have those concepts. And if we can move to the next slide, Chris, if we take a cusp line, then we can see how we can start preparing and think, what am I going to teach at the surface level? And to begin with, then you look at the understanding, see what are the key things in the understanding that the students need to know to create that understanding. And we see that materials, natural materials, process materials are key ones that show up. And if we look to the knowledge, we see they're repeated in there. So at the bottom, we can draw that down and say, well, for the students to have that understanding, they need to know what materials are, process materials, natural materials, and purpose, because we can see that process materials are manufactured for a specific purpose. If you go to the next slide again, Chris, it's again at the surface level, you're not just worried about the concepts, but you can see in that cusp line, one of the suggested ways for students to demonstrate their understanding is to relate process materials to natural materials. So what does relating mean? How do kids relate? What is the relationship? So if we're not too sure if kids know how to make relationships between things or state relationships between things, we'll want to make sure we do that at the surface level as well. So Chris and I are then going to show you how we can unpack this this cusp line on that level. Now, if you look carefully at that first cusp line, there's a lot of First Nation stuff. We are going to address it, but at the end of the day, we're not going to consider that middle piece and understanding because it's not really transferable. It's really a fact about the First Nation, Métis and Inuit culture and how they, in particular, as a group, live in harmony based on their relationship with the land. The real understanding is that that people, and not necessarily the FNMI people, but all people, their interaction with nature and natural resources is based on their relationship with the land. In this particular case, we're just looking at the FNMI relationship with the land and how that harmony and balance helps them determine how they're going to use those resources that are natural or those materials that are natural on the earth. So that will be addressed in this surface level as well. So at the next slide, we're just going to begin showing you how we can start unpacking those or working with those surface level concepts and skills.
So again, this would go back to what I showed you already from the previous grade, and that would be, this would be a good starting point for grade 3, is just going into what is materials and properties. Like, what are those terms? So how do they fit? What would it look like? And so this one will unpack that in a nice way where we can pause, we can see what the students know, what other things can they come up with? Like, what kind of list do they have? Is their repertoire and being able to identify all these different kinds of materials vast, or is it pretty limited? So do you need to bring in lots of hands-on things that they can see in pictures and kind of just enrich their environment first? Or, hey, no, actually, we got a pretty good grasp on this, so we can kind of move on. And then again, you want to just have materials on hand, not just always pictures or watching them on video. So anything that's in here are common things. And we could even ask them, you know, we could say, tomorrow, I want you to bring a material that has whatever property. So they could look around home, they could look around their bedroom, they could bring something in just as a quick, could even be a show and tell kind of thing. So that'll be an important piece. Okay, we're going to do the relationship one.
Sure. So, at the surface level, again, we saw that having kids relate things was in that cusp line, and relating things is really establishing a relationship. So I'm going to go through one concept attainment activity with you, and the process is the same for all the other ones that we'll show them. We're not going to give you all of them, but this is an important one because, again, when we get to the understanding part of all the parts in this curriculum, all the cusp line, an understanding is the relationship between those concepts. So we're going to explore the idea of a relationship a little bit through a concept attainment activity. With each of these that you have a link to, there's just the front end that gives the steps. If you've never done one before, we're not going to go through that. We're just going to go through one quickly with you to get a sense of what a concept attainment activity looks like. When a concept attainment activity, you always give examples or a yeses column and non-examples. And in this case, I'm going to show you pairs of pictures. The first pair is an example of the idea I have in mind. There's something about those two pictures. If you take a look at the lightning, we have fire, and then we have lightning and a person walking. That's not an example of the thing I have in mind. It doesn't have what it takes to be a yes. This would be one that I would probably print out and have pictures there on the wall because you'd want to be able to see the pictures line up and all the yeses together and all the no's together. But we're doing this digitally, so we're doing this. Let's take a look at the next two pictures. Take a look at them. We've got a plant and a watering can.
Right.
That's all right. And a watering can and a balloon. That's not an example of the idea that we're trying to develop. We can go on to the next one. So we've got a clown and a person smiling, and we've got this ancient kind of contraption and a clown. So if you can imagine those other pictures grouped together, and you could get more and so on, but by giving those examples, did you go past the slide or not, Chris? I'm not too sure.
Nope.
No, okay, then this a slide is missing. Then I would basically give a couple pictures that aren't identified as a yes, no, and say, well, based on what we've seen, would this picture or pair of pictures be a yes or no? And after we look at that, we see, well, what are the similarities? Here's where it's grouped. We can start defining what it is. Yeah, the similarity is that they're a relationship. It's a connection between two or more people or things. And so you can go back, well, what's the relationship between the other things? How can you state the relationship? So if you go to the next slide, Chris, yeah. We would say that the relationship between the clown and the person smiling, that clowns make people laugh, and that's the relationship. Or lightnings can start fires. So that's what we're trying to do here. So if you could see a relationship, which would be the best example of a relationship here, that there's a connection between things here. And we may point out that, well, there's a relationship in the first picture on the left because there are people and somehow communicating with each other. They're holding hands. They have a close relationship, or they're together in some way. And here we're not too sure if we see any kind of relationship between the people there that we could describe. And on to the next slide. So we're talking about relationships. We're talking about what is the connections between things. So humans have a relationship with nature. Which one of those two would be the best description of a relationship? Or are they both a relationship between humans and nature? So if we say humans can help nature, what is an example that you have to show that relationship is true? Or can humans hurt nature? Is that a true relationship between those two ideas as well? You can see now I'm starting to build lines and connecting words with that. This is a good activity to help introduce kids later on to concept maps if you want to do that. What do we see in this picture? I guess we were seeing that, I forgot to relate it to the picture, but what do we see in this picture is the relationship that humans help nature or that humans hurt nature. In the previous picture was a helping because obviously they were tree planting if you took a closer look at that picture. But what kind of a relationship is in this picture? Is what in this context, is that an example of humans helping or hurting nature? Of course, hurting nature. We go on to the next slide. What kind of a relationship do you see here? What two things are in a relationship, and what kind of relationship would they be? So you can see we're getting a bit more where they're starting to identify the ideas or concepts and what the relationship is. And we can move on to the next slide, Chris. Is this a relationship? Is there a relationship between fruit and health? If so, what word would you put in the middle? Maybe fruit helps us with our health or something like that. Anything to describe the connection between two ideas, that's building the relationship or the connection. So that's how this works on. You don't have to go through all these, because if you just maybe flip through the final couple, I think. So you can see that there's lots of practice and then giving them practice to develop their understanding of relationship. You think of two things. What is a relationship that's there between them? And again, this is just an introductory activity to that whole idea of connecting and making relationships between things. And later on, now that we've gone through this and practiced making some connections, later on, there'll be an activity that we can actually have kids make relationships with some of the ideas in this organizing idea. So anytime you see concept attainment with those, that's how they're organized. We're not going to open every one for you, go through with them with you. Again, they're just introductory ideas. You got to keep coming back to it and practicing those things. There's one way to introduce a concept. So go ahead, Chris.
So when we're talking about different kinds of materials, we want them to have exposure to what's a man-made material, what's a natural material. And in some cases, the students might not know what is natural. They may not even know that some things were put together. Maybe they don't even know where it came from. So in some cases, just doing a quick walk around even your classroom to see if they can find things that are natural in the state that they think they would have come originally. And is there something that would have been man-made? So a pair of scissors, right? They didn't just find that. It doesn't grow like that in nature. So it's a processed material. It comes from natural materials, but it's processed. And then I gave you just some links in here. Each one of these, I won't go into them right now, but if you click them on, they will tell you a little bit about salt. I mean, kids know salt, they see salt, they use salt, they have it, but what do they know about the background of it? Where does it come from? What about shells? You know, how do shells get made? What do we use shells for? Do they even know that shells are what makes their toothpaste, right? So all of those little pieces that kids might just, a little aha moment happening there. Or glass, is glass processed or is it natural? Does it come from all natural products? So again, these are just bits of information for you to take and use if you wish, as far as trying to unpack some of just that surface level information. Oh, you're muted, Ted.
I am. I've got noise in the background. I don't want to interfere with you. There's some clanging going on next door. So now, once we've had an opportunity to work at those things at the surface level, now we can go on to working at that understanding. And remember, the understandings when we get them to do an activity, we also want to get them to justify, well, is that understanding evident here that materials can be used in a natural form or process form to create new materials? Making that connection and understanding how those ideas are related is what we're really trying to get at. And then seeing that in a variety of contexts. And Chris gave some examples in the previous slide of different combinations of materials from natural process that can be used to create new materials. So it's the skills and the procedures that are going to be helping us to develop those understandings or to have student test those understandings. So always bring out the wording of the understanding when you can. So we're going to go through some activities that maybe you can that can help develop that understanding with the students.
So again, looking at, this is a particular example of where we're talking about natural versus man-made environments. So they're comparing, let's say, nature to a city. But even the city has natural environments in it, right? So it's, again, it gives the students just that another perspective of which they can now start to articulate for you, that they can see it, they can identify it, they can name it, They can explain to you what it is that's natural, what it is that's processed or man-made. And, you know, we want to be able to ask them too, if it's processed, can you tell me what materials made that? What are the natural materials that were used to create that? So if I want to talk about a chair, for example, a chair might be made out of wood. So it came from a tree, a natural product of a tree, but it was turned into by hand, by man, into a chair.
In the bottom left of this this slide is a restatement of that skills and procedure statement, which was relate or identify the relationship between processed materials and natural materials. As shown in the example, it's kind of a restatement of that skills and process one. So if we've gone through that practice concept attainment with students, they should be able to do this. It's going to take a little bit of research or something to maybe find what some of those were, or through some of the previous activities that they did at the surface level, that they may know what some of these things are made of. But what they need to do is make the relationship between something as a natural material with a processed material. For example, if tree, popsicle stick, and toothpick were thrown in the mix, I might make this kind of a relationship between those three. So if we look at it carefully, there's some similar three, a triad that can be put together just to get that practice with building that relationship, putting it together and stating that relationship, that this, and you could separate out what is manufactured and what is natural. So they know what those two are, but they also can state the relationship on a really basic level. And again, this could be these kinds of things, getting kids to work with concept maps are really good, quick ways to demonstrate at a very formative level their understanding of those things. They couldn't put those together if they didn't understand the difference between natural material and processed material, right? Because the tree would have, for example, in the case of tree, both things go to tree. And then when you have them explain it to you, they're going to say tree is the natural material, toothpick and popsicle stick is the manufactured material. So it gives you lots of information when kids talk about the relationships that they made.
And just as an FYI, that link that I gave you for glass, if you've never seen glass made, it's a great little video to watch with the students and just to see how they take sand and compress it to create the glass that we use on a day-by-day basis. And this is just a slide, I won't go through it, but just some Q&As, right? So that we can ask them, explain why the statement is true, both natural and processed products come from natural. So I have to start with natural things to create a processed one. And that's why it's important for them to articulate what they think was used to make that processed one. Or can you tell me about something that is classified as processed? So just doing the flip side of it. So again, it's just giving them an opportunity, whether you want to call that a slightly deeper one because they're now getting to choose their own. Maybe it's an independent work where they get to do this answer. So you're getting a sense of who's got the idea and who doesn't. And again, just some side suggestions for you that you could use here for different kinds of assessment, whether you want to use it as deeper transfer. Some examples of processed ones. Research 5 of the processed products and address the key points on the whiteboard and find out what they're supposed to have, like what was it made of, right? So they can do a little bit of research on their own. This is the statement to follow up that Ted had mentioned to you before on the First Nations, that it really isn't an understanding. It was just a statement. It was a statement that said, this is a statement of fact. So although it's sat in the understanding, there's no concepts to link to that to bring anywhere else. It was a statement of fact, but it's still information that we need to teach the students. So the interaction with natural materials is guided by the relationships with land. And that goes back to that opening comment that I made. And so I provided you with a lot of different resources here, depending on, again, your backgrounds and where you live and what you have access to for Indigenous culture to be incorporated within your curriculums. You've got some resources. Every one of these are hyperlinked. But in this case, we're looking at sort of the summary of what First Nations used for living off of the land. What was it that they used? What were the important pieces? What were the tools that they created from the land? What was the food that they used from the land? So again, looking at just the natural perspective. And then the same thing here. If we go back in history and currently as well, what is the importance of the buffalo? What is the seal used for if I'm looking at Inuit society? How important is snow? Very in wintertime. It serves as shelter, it serves as warmth. When we talk about natural things, a Red River cart, some of your children might not even know what a Red River cart is. They might not have ever actually seen one. So again, you can get miniature versions of them, but they need to know that it was just made out of wood. And the Red River cart didn't have any metal at all in it. Anything that held the wheels on, the axles were all done with wooden pegs. So a true Red River cart is 100% natural. Even though it doesn't look like a tree anymore, it's just made out of the wooden tree, and that's how it was. So I gave you some factual information about it too, if you haven't got anything on it, just to use it as an example, as opposed to a truck, right? Here's a processed material of metal and another way to transport, and very more like what we're using today. So it's just having that processed versus natural opportunity for them to discuss. And how do I compare them? How do I look at, obviously, the speed, the ability to go further, etc. is better with the truck, but they both carried some commonalities, right? They both were able to transport people and items, etc. So there's your Venn diagram coming in. Again, depending on your background and what you have available for resources in your school, birch bark is another one that is still used today, but birch bark canoes made out of birch trees, birch bark itself. Birch bark biting is another one that is another piece that's still very much being used today. So these videos here will give you some background on some of these pieces if you're not familiar with it, or if that's not the culture of your area, then you just might want to skip that one and pick something that's a little bit more relevant to where you live. We're looking for things like the Inuit grandfather, grandmother series. These books here are slightly young, the way they're written for a grade 3 student. However, the contents of them are still really relevant. So that's why I left them here, but I also included some videos for you so that you could take them a little bit deeper to understand, how do I use the natural materials of snow? How do they use that in order to survive, live off the land? What purpose does it have? How did you make an igloo? Is the igloo just sitting on top of the snow? And the answer is no, it isn't. It's actually dug down, because if it was just on top of the snow, a polar bear can just dig his way in. So there's got to be another way for them to create the entrance. The entrance is a certain number of meters long so that a bear doesn't fit into it, etc. It's actually quite interesting. All right, let's go. The other one is the most important piece for, especially in Cree culture, is the buffalo. For all cultures, for Indigenous, but in particular, when we talk about the buffalo, there's nothing on a buffalo that wasn't used. Everything is used. And still today, when they do buffalo hunt, there is nothing about a buffalo that is not used, right down to the last hair, last hoof, last nail, tooth, sorry, everything. So again, in here, what you'll see is just the uses of all the different parts of the buffalo. And that's just straight land use. Again, how I use the natural product that's available to me. In this case, it's an animal. And there's a link for you if you need some more information. We know that there are 4 sacred plants, medicines that are used. And again, these are some of the lower end books. The books are the only ones that we highlighted for kindergarten, grade 1, grade 2. In grade 3, I've included some videos for you that are attached to it, because it's important that they understand why, if you have an elder that comes to your classroom, are you using tobacco? Why are you offering protocol? All of those pieces are linked directly to those 4 plants. So again, those are natural, directly off the land. And further information about the medicine, the natural medicines that are found within the plants. These are slightly longer videos, hence part 1, part 2. So I would watch them ahead of time, and I would even suggest you might even want to just take snippets of each one to highlight the piece that you want to talk about in class. The tribal trade videos that we have are usually quite short, and they help to give background knowledge. So if you're not familiar with them, you might want to watch one. Why do they smudge? Why is it that smudging is important? What is the belief, and what is the value for connection to land on that? Okay, so let's move on here. I just want to start these without having my video start. And the last one that you have here is one on the Inuit culture. And so again, you've got a number of different links on here. This is from the Cultural Institute for Nunavut. So looking at what they offer, this is the link in here. It also has sort of collections, sort of like 3 categories of information that you can draw from if you don't have a lot of Inuit culture information that you want to draw into your classroom. And then there's one called The Land. When you click on the collections, there's one called The Land. And if you go into The Land and select Our Tools, you will get an immediate sort of list, both in the Inuit culture, or language, but you also will get a list of what do they use from the land as tools to survive. And that's one of the pieces that also links from grade 2. So again, just a bunch of pieces in here that we need to add to their knowledge, but it's not necessarily an understanding.
Now that was working with that first cusp line, and we're going to move on quickly through the others. In some cases, especially in matter, there are a lot of cusp lines. I think there's 5, maybe 6. Correct me if I'm wrong, Chris. But anyway, yeah. Sometimes they could be combined because they're so closely linked together. They're separate understandings, but it's probably better to work with them together. And this is a good example of that. And so in this graphic, it's a little bit different than the other one. I didn't list all the statements in the knowledge part. It would just take too much room. But again, pulling out those key concepts that we want to make sure students know before we get to the understanding piece. If you could take a look on the right again to the skills and procedure, you could see that to demonstrate this understanding or to develop those understandings and work at that deep level, students are going to conduct an investigation or discuss or describe. We'll talk about conducting an investigation later on. That's one of the key skills, of course, in grade 3 science and in the science program from K to 6. And that's, we'll take a look at what is an investigation later on. So we won't address it as we unpack this cusp line. And discuss and describe the skills we're shown further up in that backgrounder part that Chris showed. So we won't necessarily be getting involved into those pieces when we unpack the surface level parts of this particular cusp. Chris?
So really what we're looking at now is we're looking at states of matter. And as Ted said, it was really hard to take those 2 different cusps and kind of treat them separately because they're so tied together. So we're really looking at what are the 3 states of matter. We're looking at what happens when I add heat, for example, into those states of matter. Again, I'm looking at what are some natural substances, and do those natural substances have different changes in states? If I add heat or not add heat, what happens to them? So this gives us a chance to discuss also sometimes when we make a change, we can't reverse it. It happens and it's permanent. So for example, frying an egg, right? That's definitely a change of state because I can't take the egg and let it cool off and poof, it's back into its shell again. Whereas if I take water and I freeze it, I can let water melt and come back to my liquid water again. So those are the terminologies that we want to talk about, is what are some of the things that are reversible and what are some of the things that are not. So we're going to talk about permanent changes and reversible ones, and then we're going to finish off, and it's not in the order, and you're never as a teacher required to teach any of those new curriculums in the order that they've been presented. You need to put them with things that fit together or in an order that makes sense for what you're going to do. And in this case, we're going to teach all about the different things that happen with matter. What are influences that heat has? So that in the end, we want to kind of finish with what is the defining cycle. And in particular, we're going to talk about the water cycle because that's the one that has the most changes in it. So that's where it comes into play.
So at the surface level of this cusp line, you'll notice that there were a lot in that previous graphic that I showed you of ones that would be at the surface level. But the chances are they've already, if you can just back up one slide, Chris.
Sorry, yeah.
That's all right. The chances are they've already you don't have to go all the way back to that one. I just meant to that one there. But I'm just gonna have people recollect their memories. There was a list of concepts there. Most of them were already covered in the previous organizing idea, or ones that if you probably assess them, they would probably have already. But a new one that comes into play quite a bit is the concept of change. So we're going to pause and take a look at that. We're not going to open up these things up. We'll open up one thing, but the first thing there that you see, there's two links there. One is just an activity to help. You don't have to open up that one, Chris. We'll open up the next one. Just an activity similar to a concept attainment activity, examples, non-examples of what change is, to develop the idea that change is this means it's whatever over time something is different than it was before. And then I'm going to introduce to you a template that you can use, and a Freire model template is just as good. And these would be good ways to get kids or your students to keep track of the big idea concepts, and they could build these and have a collection of these as study guides or something if you want to have that. So after running that activity, then you could open up this template here. It's called State, Elaborate, Exemplify, Illustrate. So you've been through that activity and you define the idea, the concept together. Then in this sheet, the students put the definition as clear as they possible, and they elaborate, which is the C. In other words, here's what it means in their words. And when kids can put a definition in their own words, they've got a really good, there's a good indication they have a deep understanding of that concept. And then of course they provide examples of the concepts. So in this particular case, what are some examples of change? And if students can illustrate that, it's really a good thing. They could illustrate in a picture, or they could illustrate it as an analogy. And a lot of kids can think that way and helps them to remember there. But illustrating it either through a metaphor or a diagram is another powerful way to help kids to deepen their understanding of a particular concept. So that template is there. You could do with any of the concepts. And I should have had a Freire model attached to this. But those of you who are familiar with the Freire model, that can also be used for kids to keep track and keep adding to their collection of concepts that they're learning at these levels. Go ahead, Chris. Yeah, I think here.
So one of the things that some of you who know me from way back, I'm big into foldables. Foldables are graphic organizers, and the Matter unit was a perfect place for a foldable. So you will find in your resource package a foldable template. In other words, what to print off and to use for this. And really what it is just a place for me to have students write down some of their learnings in their own language, not copied from the board, not copied from a book, not copied from anything, just in their own language, because that's what the power of that will be. And then you see these little pockets that are underneath here. That gives me a place where I can start to identify what's the difference between solids, liquids, and gases, my three states that I'm learning about. I've given you a card sort in hexagon shape. That's also one of the sheets, so we can cut that out and kids can go ahead and put them into their foldable. Whether they cut out their own or whether you just have some that you use year after year after year and just bag them once and laminate them, that might be the faster way for you, but that's entirely up to you. And if you want them to have them, then it gives them that opportunity. And it will culminate with going into how does heat or temperature affect any kind of state of change. So we're going to talk about what happens when I add heat to ice, what happens when I add heat to chocolate, what happens when I add heat to ice cream, right? And then what are ones that I can take back to its original form? Can I go back and make it what it was before? And that leads us to the conversation, as I said before, of the water cycle. So this would be a good introduction when we're talking about states of change and what's permanent and what's not permanent. Here we see sage being burned, and often if you've ever had smudging first thing in the morning because you've had a session or you have it as a standard practice at your school, you probably are using sage, sometimes sweetgrass, for the smudging that happens. But as this is burning, we want the kids to think about, is this going to come back to its original form, or is this going to be a permanent change? So hence the reason why we had the picture. Okay, what other changes do we see here? And I wouldn't tell them what I'm looking for here. I would just say, what do you think? How has the sage changed? And they might say, well, it's burning, it's going to be ashes. Great, that's the observation I'm looking for. What about in pictures like this? What am I seeing? What kind of change can they describe for me? So I'm seeing ice, I see water, I see steam coming out of a kettle. And some kids will already know that that's the connection between the three different states of water. Some of them won't connect steam to this picture at all. What about ice cream, right? I have ice cream, I have melted ice cream. So can they describe what's happened from an original to here's another situation, still ice cream, just doesn't look the same. So in this case, I'm not a stand up and deliver person. I would prefer that I might watch a video with them and let's see if we can glean the information I want them to learn out of that and ask them questions when it's done. So in this case, watch the video and learn about states of matter. Maybe they already know them, maybe they don't. Most of them won't. Write down the examples that come to mind. So maybe I start partway through and say, you know, you saw this state of matter, you saw this one. Okay, did anybody remember any of the ones that they saw? Can you come up with your own? So again, it's just that one step further to see where we can find it. Listen for the characteristics of each state. What am I looking for there? I'm looking for, well, if I were to take ice and put it in a glass, does it react the same way as I put water in a glass? So solids don't take the shape of the glass, whereas the liquid does, right? That's a characteristic that we want them to be able to explain to us. And that's also in the card sorts that I gave you. So states of matter, you're going to do some of those same cards that they just put into their foldable. We might even want to talk about, again, can I just redo them? These are the cards that you have to work with. Whoops. And so in here is also built in some of those characteristics. So is a liquid always going to have a specific size? Is a solid always going to have a specific size? Does a gas always have a specific size, right? Which ones do those belong to? In some cases, maybe there's more than one it belongs to. So that card sort again becomes an important piece. Then rewatching it is just a suggestion, but I would rewatch it again. And can they now just name those states? But also, can you take some of the blank hexagons that we have and come up with your own examples? Let's write some on them, such as honey. Honey is a liquid. Can honey become a solid? Some kids might have seen that. Some kids might not have seen that. If it's a solid, can I turn it back into a liquid again, right? So just what are some common examples that you can have to talk about the term reversible and permanent? When are things reversible? When are things permanent? Give me examples of both. And as a team, you might want to, because that's sometimes a little harder for the kids, have them work in pairs to come up with some new ideas. Which ones can they come up with? 2 more permanent ones? Can they come up with 2 more reversible ones? And Ted has a great activity for you.
Well, you know what? I made a mistake and I threw it in here. It was just one of these last ones because probably better at grade 5, grade 6, because we're talking about sort of a change of state. Certainly, when we shake the soda bottle up from getting, in a sense, because the gas is coming out of liquid, so it's not necessarily a change of state. So perhaps in the wrong grade, but again, it's a good little experiment to talk about what might happen and investigate that. But I think, Chris, this should better belong in grade 5. And we're talking about the particle theory of matter. So,
well, and I might even say that I think all of you will welcome bringing pop bottles into the classroom and having the kids shake it up. Like, I can't wait to see how well that goes over. I laughed the first time I saw it. I thought, yeah, this is great. I would do that. I think it would be fun, but it would be dangerous.
So for some deep activities, we didn't have a list there, but when you take a look back, there are some of the videos that Chris suggested there would be some good things there. But when you take a look, you would have to go take a look back. But if you remember, I said there are 2 key doing parts in the skills and procedures, and that was conducting investigations. So that would be where you would have kids ask the question and in matter change, if it's heated or cooled, what's an investigation you can do to determine that? So that's where kids would be setting up an investigation, asking the question, making a prediction about it, doing that little test on it, and then collecting data and then making a conclusion. We'll go through the steps in a little bit, but those are some of the deep activities that you can do to develop those understandings. A second last group of cusps, we're looking at these key things, and we've covered this quite a bit already with permanent, reversible change and so on. So it's a fairly straightforward cusp to go through. So we're also then exploring the ideas of melting and freezing points with this one. So we'll take you through surface level activities that can develop this pair of cusp lines. And you can see explore, for the most part, is going to be observations. That's how they're going to explore, and they may be doing some testing when they're exploring as well. Chris has used a lot of, we'll show you how you can do a comparison example with this one. And of course, experiments or investigations are also part of this one. Chris?
And I just want to point out a little bit of a disconnect here. In your understanding, it talks about freezing, melting, boiling points. And I suspect that the boiling points is showing up in the understanding more as a, can we look it up? Can we find it? When you're looking over on your skill and procedure side, you're not seeing that they're actively engaged in exploring boiling. So I suspect because of safety, that doesn't mean you couldn't do the demo. So just so that you know the differences there. So again, we're talking about what are some permanent changes, what are reversible. So we talked about that already. So they've done some of that work. I might want to go a little bit deeper, watch this video, what happens when I heat things up. And this gets very much to the particle movement inside. So it is a little bit linked to grade 5, but still fits very, very well into here, because really that's what it's getting to. And then we might ask the students, identify whether these are reversible or permanent changes based on what I watched here. What happens when I burn a candle? Is that a permanent or is that something that's reversible? What happens when I burn a piece of paper? Kind of like my sage, there's my connection, right? Growing in height, right? Is that permanent or is that reversible? We don't usually shrink. A popsicle melting, can I refreeze the popsicle? So it's just, again, giving students that opportunity to see it in another context. And now they should be well positioned to be able to give us that language that we're looking for. So again, you might want to compare the melting, freezing, maybe the boiling points if you're going to do it as a demo. I suspect not as a hands-on for the students to do in grade 3. And then again, you want to know what are the temperatures even at room temperature? What do they do at room temperature? What do you have? I have honey that's flowing slowly, but at room temperature, it's still liquid, right? So what is happening at room temperature versus when we add some heat to it, or we put it in the freezer with a thermometer and sort of monitor it from there. So you might want to do a prediction. Want to talk about that, Ted?
Oh, yeah, sometimes you could do a prediction by doing a spectrum sort where they had the cards, if this was a cutout for them, or if they had a digital manipulative, where do they think is going to be the hottest boiling point? Or you put melting point for the activity that we're really working with here. And Crystal will continue it on the next slide, but what would be the hottest? And they would take one of those words and put it down, and the freezing point as well, maybe a similar thing. But spectrum sort is just taking two extremes and having kids put their ideas on the spectrum, and then perhaps be able to justify it, or later on test it out and then come back and see if their prediction was correct. And that's part of the investigation process, is making those predictions. So once those are done, then we can go on to collecting some data, right, Chris? That's the next slide.
Yeah, exactly. So they could, and I'm just giving some suggestions here. I'm not saying you have to use those. You might want to have different ones that you have available to you, use whatever, but just easy substances that you can measure at room temperatures, substances that you can maybe put in the freezer, put a thermometer in there with them, have them check it. I've got some pointers on the side here, check it every 10 minutes. And then when it freezes, kind of what was the thermometer reading, and then take it back out, put it on the counter. And when you start seeing the first melting happen, what temperature was that at, right? So just for the kids to have an opportunity to see what that looks like. And just describing, again, the terms and things that they've seen. So a couple of resources that we have for you. I'm going to share just some of those with you now. Again, some of these books might be helpful in your in-class library. I'm not suggesting that you'd have one for every student at this point. We're not sure yet if any of these will make it to the New Learn Alberta site. So again, that might be a possibility. But Nicole Lamoureux and I are going through a number of resources right now and just reading books that have been delivered to us so that we can see if there's any. This is one that I thought was really good, and it fits very, very well with the grade 3 curriculum. And it's called Changing Matter. I'm using the top, got cut off there. So it just looks like this, has a little car on the front of it. All of these are made by teachers. They're called teacher created materials. I've given you the ISBN numbers, and you'll have the link to the to the authors and whatever in the series as well. It'll be in the sources at the back. Another possibility might be that you want to look at having centers set up in the room, and everybody does one different one. So there's their experiment, right? Exploring, as Ted just pointed out in our skills. What happens about candles? What happens about swirls? What happens about lollipops? So here's just some, I've matched them, color-coded the description to each one of these that are hyperlinks. You just need to click them on so that you have some activities that you might want to choose with the students. So go through them first and see if that matches to anything that you want to do.
This slide has a mistake on it, everyone. I apologize. Cycles should be there as the concepts on the left, but we should have some other concepts on that knowledge piece, such as cycle, not only cycle, but water cycle, evaporation, precipitation, condensation. So we'll fix that up when you get your slide that you can download. So those are the key things we're looking at. We're looking at the water cycle, and that the earth and water continually moves that way. So kids are going to be doing such as diagramming or representing, discussing, and you can see discussing and representing is a big part of this cusp. So Chris?
You bet. And the reason we put that at the end is really because if I think about all the things that I've learned about the different states, about the different ways of material changes, in this case, my object or my material is water, what are the cycles? What does cycle mean? So we learn about a cycle. But then this is kind of the culmination of everything. The sun is my heat source, and it changes what happens. It evaporates the water, and then the water comes up, cools off, and starts to condense, and I get my water droplets, right? The precipitation. So it's really shouldn't be at the front. It should be at the end, because now I can use all the language that you've taught me, and I can start to do some good explanations. And that's the piece that we left it here. So what does it mean to cycle things around? Sometimes we say that to kids, we're just gonna cycle these around or recycle things around. What does that mean? And then can they name some cycles? Well, they've already done cycles in time. So in the new grades 1 to K to 4, you have a time unit in your math. And we've already talked about cycles, and they talk about seasons. So again, this is an opportunity for us to bring those connections back into it. And then how do the different states of water represent a cycle? How does that work? Do you want to go through the concept attainment one here? No? Okay.
No, most students would probably know by now through their math what a cycle is, but if you want to make sure you can try to do that, there'll be a link to that available for you if you want.
Okay, so we might start off with just a graphic like this, letting them see dinosaurs drinking water, right? With a caption that says, the water that we drink today, because it's in a cycle, is the same water that dinosaurs drank 3 billion years ago or whatever, right? Just millions of years ago. It's a good grab for them to get their eyes open. And they think, well, how's that possible, right? So then we talk about that cycle again. So it's an opportunity for students to start to connect those pieces about the cycles, about different states of matter, in this case, water, which is a rich one to talk about, and develop the notion of how does the water cycle impact us. So this is a video on the water cycle, which just unpacks it. Remember, part of that's also in their foldable. And again, there's some questions in here. They've got some links in here. The PBS video one is a series for you. It's very segmented, and you can just take parts of it. So if you've never actually visited PBS videos for teachers, you should actually subscribe to that. It's free. And they have a ton of educational videos, and they're always very short, sweet, and appropriate to what we want to teach them in a short form. Whoops, sorry. One of the other books that is a really good book, I got this one from Scholastic, is The Water Cycle at Work. How does it work? And here's your table of contents that you can find in there. And here is your author down at the bottom. And the other one that just recently arrived, and it's an excellent book. I mean, if I was going to say, of all the ones I show you, this is one that I would purchase, because this fits to our curriculum perfectly. And it talks about the water cycle, and it talks about just some pieces in here, and it diagrams it out for them. And up front, I've just given you a screenshot of one of the pages, which basically looking at what is a cycle, and they equate it to a Monopoly game so that the kids start to get connections to this. So it's a great little book. It covers all of our states of matter as well, and that's the kind of things that we want. So here's a good deep question, right? If now I understand, we've unpacked all of this terminology through this whole unit. Precipitation replenishes water on Earth. Demonstrate how that works. What have they learned from all those videos, especially the water cycle? Making a water cycle in a bag, right? If I heat the bag up and the water condenses against the plastic and drips down again, they can create a water cycle in a bag. So that's a great little experiment that they can go through and do. Scientist Sees is another great one. It talks about your scientific method and really focuses in on a number of things. Within there, it talks about the scientific method, and it also talks a little bit about an extension of that, which is appropriate for the grade 3s. States of Matter. This is another one which is comes right out of that book, but it also just makes them start thinking about the food that they're eating, right? What are the states of matter? What are the properties of spaghetti? Can I stretch it? Can I bend it? Can I break it? Right? So just change the context in which the student is seeing things. Okay, that comes from a book called The States of Matter, and here's all the information that you'll find inside of it. All of these are listed at the back. This is a really good book as well. So again, solids, liquids, comparisons, ice melting, solid or liquid is the name of the book. So it's very specific to state change. And Analyze It gives them an opportunity to think about, what do I need to remember about an experiment? What are the things that I need to include in that? So here are the steps that we would talk about. Ted will unpack scientific method for you right away here. There's another book series. It's graphic, cartoon oriented, and it comes from one of the series that was put out. It's an older series, but it's still available. And it talks about, in this case, states of matter. So it's done with Max Axiom, who's kind of the hero in this, kind of like a Superman hero. And he goes through and he does all of the solutions and questions and problems that you want to solve, but does it in this graphic organizer form. So kind of a nice way for the kids to see it. Another possible assessment for you: compare and contrast a liquid with a gas. What do they see? And the last slide is really just a slide for if you want to do a quick review with students of everything we learned in matter in grade 3. Here it is. Let's run down it. Or can you give me an example of each circle? Or is there anything as we go through this that doesn't make sense to you? You don't feel like you're comfortable in it. Just as a quick review, or however else you see you want to use that. Other than that, you can just ignore that slide. So here are some additional resources. You will find here that this gives you the properties of matter. It's already a slideshow. They give you the PowerPoint that you can use. And then again, the Chemistry for Life is an entire series of 4 lessons. I won't go into these because you can access them for free. So that's why the links are in there. You also have, this goes with the Grandfather, Grandmother series. If you have that book, there's a teacher's guide that goes with it, questions, worksheets that you can do, little quizzes that you can do. So they all fit with that series that you saw. Whoop, we already did that one. And then here are the books that we were looking at. The books that, in particular, the small books that I just showed you, are part of the Pearson Spark Library as well. And if you wish to have a look at some of those books without buying them right off the bat, you want to read them first, like you can actually read them from cover to cover, you can have a 30-day free trial. So just click this on and you can go in and read whatever books you think might be useful, and then it would give you a better sense of what books you might like to keep in your classroom. And again, here are some of the links to the books that I just showed you, their sources. All right.
Just looking at time, we're a little bit long here. We're going to be brief. We are going to be talking about assessment a little bit more detail in some other sessions as we go along here. So, but just one thing to keep in mind is that with all these activities that Chris has laid out for you, you can do that triangulation of observations, conversations, and products to really see where the kids are at with their understanding of not only the concepts, but those understandings themselves. And at the end of the day, remember, if we go back to one of the original slides, that surface deep transfer, one of the things that really changes with the understanding to know if they're getting deep in getting it is to change those contexts. And Chris just went through a lot of different contexts that kids can explore that understanding in. And so the more they do, the more transfer is going to happen, and then they can become a summative assessment as well. So just keep that in mind, and just always remember, you don't have to necessarily use the skills and procedures that are the skill word that are provided in the skills and procedures document, because you could choose any of those verbs in that one list that I showed you near the beginning of the slide deck, that students do any of those things to demonstrate their knowledge. So they can discuss something, one of the understandings to demonstrate the knowledge. They can represent their understanding in a diagram or an infographic or something. So there's multiple ways and verbs that can be used for them to demonstrate their understanding. So just keep that in mind when it comes to assessment as well. Well, again, we'll take a closer look at it at a future time here that we'll share with you. Just very, very quickly, I want to talk about computing science and how it relates to grade 3 matter. There's some links to some recordings there to help you understand a little bit more if you haven't seen those. I'm not too sure if is that 12-minute recording for grade 3, Chris?
I haven't received it yet, but it will be probably in there by the time you guys get your slide deck. So it'll be there, and I'll put the number of minutes. They're usually short. Ange does a great job. Ange Deering does a great job of linking it specifically to grade 3 or grade 2, whatever we're talking about. In this case, matter. So she'll give you a way that you would teach computing science in matter for grade 3.
And this graphic is there just for you to look at, to maybe get a sense of what computer science is at the primary level. All the yellow things, when you take a look at them, are students following instructions. And you can see where grade 3 fits in there. They're not so much following instructions as they are moving down the road and creating instructions. That's what the pink things are. The creation of instructions get a little bit more complicated as we go along. And one of the things that is not on there, and it should have been, and I'll put it back on there, students at grade 3 are introduced to computational thinking, and there's different components to computational thinking. One of them is algorithmic thinking, which is making instructions or creating steps and sequences of things. So that's why that pink keeps on going into grade 3. And in grade 3, that's where you're going to be introduced to the 4 key things with computational thinking, one of them being making up rules like the pink line shows. So that's a brief look at computer science, and Ange will have videos available for you to unpack that computational thinking piece a little bit more. That's available. Those will be available on the ARPD site. Scientific methods, want to just point this out to you. There's again, there's going to be some videos from Nicole Lambrou, right? She has some videos that help talk about these things at each grade level. What is scientific method means at grade 3 level. But I do want to point out the grade 2 scientific methods, because that's the investigation piece. Those are the 4 steps you could see, not 4 steps, 6 steps you could see there. You will not, if you go to computer or scientific methods in grade 3, you will not see the steps there. You'll see statements like in the grade 3 column. So you have to go to the grade 2 organizing idea to see those steps in an investigation. And you can see that I've color coded them so that you can see the progressions of how they're worked through with each of the grade, each of the different colors representing a different step. So you'll certainly want to go to that grade 2 curriculum to take a look at that, and perhaps even look at the grade 2 video that Nicole has produced for the grade 2 teachers. Chris?
That is it, everyone. We apologize for going longer. It just seems like we never have enough time to go through some of these slide decks to give you everything that you need. I'm going to just put in the chat box quickly before we stop recording so people have it. I'm going to put in where you're going to find everything. And so for those of you who are unaware, the Moving Forward site will be closing down at the end of June 30th, because we're dragging everything, for those of you who've been going there, we're dragging everything and putting it into the arpdc.ab.ca site. So it's still stuff in there right now, and some of it was still updated, but for the majority of it, we've already started to transfer it over. So it'll be a one-stop shop sort of going to the ARPDC. So when you get into that, you just simply select new curriculum. And then you can, in the boxes that are there, you can select science, you can select your grade, and then it will help to filter out what's there. Otherwise, you kind of have to scroll through because they will post the most recent information at the top of the general site. So this will be our go-to site from now on. You will find your slide deck that we had today, anything that we have that's a resource, like printing out a foldable, whatever. All of those are also posted always right below the videos. So that's where you'll find resources like that. Any of the slide decks, the concept attainments, all of those pieces will be in either the link within the directing pieces that you have in the slide deck, or you will find them in the extra resources. Okay, so I'm going to stop recording now. So if anybody has any questions, and you don't have to feel like you're being recorded. So let me just change that right now.